Welcome everyone to today's webinar titled Oracle 12c Features Everyone Can Use. In today's presentation, I'm going to introduce you to some of the new features of Oracle 12c that you should be able to take advantage of regardless of whatever database edition you might have. It's not a complete list of things we'll cover today, but rather a list of features that I consider long overdue and also might give you some reason to start your planning for the upgrade. I'll also talk a little bit about the multi-tenant architecture and how you might be able to take advantage of that even if you have standard edition. A little bit about Neovera. We're founded in 2001. We're headquartered in Reston, Virginia. We are a provider of complex hosting solutions, leveraging over a decade of technical expertise in IT consulting, managed services, data center services, and enterprise cloud solutions. We've grown to support hundreds of diverse client systems across multiple Tier 4 data centers, and we are a vendor agnostic hosting provider with 24/7 operations based on-site at our Equinix data center compound in Ashburn, Virginia, which is one of the largest internet and mobile traffic exchanges in North America. A little bit about my background. I am a certified professional. I have over 16 years experience working with Oracle and Oracle products. I've worked in various industries, healthcare, manufacturing, government, financial. I have been a presenter at other Oracle users groups, taught Oracle DBA and PL SQL classes. My background does include work performed as DBA, data modeler, consultant, and I have designed and managed a variety of different types of environments. Some of the new features that we're going to talk about today, I put them in a few different categories. Some of them are going to be relative to performance. Some of them are going to be relative to new features for backup and recovery. Some of them will be applicable to development staff or development on the database itself. And some of what I'm going to talk about today should fit some of these benefits, if not all of them. And that'll save you time. It's less complicated or reduced steps. So there are some features that, although they existed in 11G, they've been enhanced in 12C to be a lot less complicated, more efficient, and to make better use of your resources. With that said, I'll get started with one of the first ones is default values. So these are default. You can now define a default value based on an Oracle sequence. Basically, you alter the table, you add a column like you would normally, but now you can specify the default for that column, in this case being a sequence value. In my testing of doing the default value versus the old method, which was the trigger method of populating it or selecting from a sequence and then populating the value, I did a test with only 91,000 rows and an insert with the trigger using the old method, 7 seconds. Doing it with just adding the column with the default value for that, 2 seconds. So a pretty good significant change in performance on that. It does, I think what equates to most of that time is the reduction in the number of recursive calls that it makes. When I did that with the insert trigger, that turned out to be 95,000 recursive calls to populate every one of those rows. With the insert with a default value, it was only 5,000 recursive calls. So I think that's what's accounting for the big difference in the performance gains. You also can do default values based on an explicit null. So a lot of times in what we used to do is in the trigger, we would put if the value's coming in as null, then get the value from the sequence, populate the column, and do that behind the scenes. Now you can do that all with the same alter table statement added, adding that sequence and actually saying only do it when the value is actually coming in null. I did see the same type of performance with this as I did when I did just the default sequence value declaration. And again, that performance was with those recursive calls. This is something obviously that's long overdue and gets the DBAs out of actually creating triggers to do methods for populating primary keys or surrogate keys. Identity columns. So now we've caught up with Microsoft SQL Server on this and other databases. Oracle behind the scenes does use an internal sequence for those values. When you define a column as an identity column, it creates a I sequence $$ and then an actual number that's associated with that. It populates the data default with that sequence value, the internal one. You do have control over the sequence settings, just like you would if you did a create sequence statement. So you can actually specify the starting values, the increment values, the cache values. Obviously, those would become more important in a rack environment where you need to be able to cache or change the increment by. The column is created as a not null, and that number generated as a this is the syntax you would add to that, number generated as identity. There's three different methods or three different approaches to identifying it as an identity column. If you do a number generated as identity with nothing else, you cannot override the value and you cannot use a null value. So it's always going to be there and you can't change it. You can specify number generated by default as an identity, which does allow you to overwrite the value if you wanted to supply a value, but again, it cannot be a null value. And then you can do number generated by default on null as identity. And in that, you can actually override the value and you can use a null value, but the value internal sequence will be used. So if you pass it a null, it will actually populate it with the sequence. In the other two options, you can't pass a null. You must supply a value. So it's nothing really magical about this, but it is a nice addition. You can also do metadata only defaults. So and this is the case where you add a column with a default clause that it's a metadata change only. It's not null or you can add it as not null or nullable. In Oracle 11G, we had this functionality, but it had to be not null. So now you can actually do the nullable. The default values are actually maintained in the data dictionary. You can see that when you query the data dictionary. It does not consume any extra space when this is done. The beauty of this, which you couldn't do in 11G, is this is done in seconds. It doesn't matter if it has 5 rows or 5 million rows. It's literally done in seconds compared to the 11G method. In the 11G, you know, if you had a billion row table, you added a column with a default value, you basically waited until all those values, it scanned that and populated that. And in here I did an example with 1.4 million rows in 11G R2. I added just a created date and I set the default to be sysdate. That took approximately 51 seconds. The same exact operation in 12C with a little bit more rows, that happened in less than a second. So this is a huge benefit for being able to make changes to your database without impacting the applications as much. varchar2 has now been changed. So you can go to 3276, 32K roughly. That's increased from 4,000 in previous versions. It is, when you specify this, it is considered an extended data type. You do have to do some things on the database to make this available to you, and one of them is you must set this parameter max string size extended. The normal default value is standard, and that is pre-12C functionality. The one thing that you have to do this, though, and why I put this note, think before you act, it does have repercussions on your database. So this is one of the features, nice to have, so that you're not specifically declaring something as a clob to get this size. You do need to think about how it's going to impact the entire database. You do have to actually go through a process of bringing the database in upgrade mode first before you can actually take advantage of this. And once you set it, you cannot go back. Once it's extended, you can't go back and alter system and set this to standard. And then following that upgrade mode, you actually execute a script that does some internal changes. It's still stored as an out-of-line lob, but it does allow you to use whatever programming language you have that supports this now doesn't have to deal with CLOBs or LOBs. It can actually deal with the actual VARCHAR2 data. Some of the considerations you want to take into account before you decide to do this is that index keys still have a size limit. So if you add a VARCHAR2, this new VARCHAR2 data type to your table, and then that is one of the columns that has an index, you still have a limit on the index key. So that is currently an 8K block size is about 64,000, 64K. So you still can't exceed that index key size limit. Virtual columns could be affected. So if you have virtual columns that were VARCHAR 4000 and now they might be increased to this new size. Views can be affected. So any views that are based on tables that have this new size, they would be affected. Materialized and consequently materialized views could also be affected. So it's a little bit more of a cascading. It requires a little bit more thought as to taking advantage of this feature. But you do have it available to you. So this is another feature where we've kind of caught up with some of the other RDBMSs. You can now have select statements send results back to the client straight from PL SQL. This obviously aids in migrations if you're going to convert from, let's say, T-SQL code into Oracle. You would now have a migration path for that emulates the same functionality. It eliminates the need of an explicit ref cursor. And it does introduce two new package procedures in this to implement this, which is DBMS SQL return result and get next result. The old method was generally you had an out parameter declared in the procedure, you populated that parameter with the cursor results, and you return that parameter back. Now you don't have to actually declare an out parameter for procedure. You can actually open the cursor for select and call the return result with that cursor, and that will return the results. There are some new JDBC functions that were added to support this. It also works in SQL+, so you could actually go into SQL+, have a procedure that opens up a cursor as select, and when you execute that in SQL+, you'll get the results back just as if you've done a select from the table. So this is actually pretty neat. Not just for migration paths. Query row limits. Again, we've caught up with some of the other RDBMSs. Now you use native SQL to limit the rows or start at a certain position in the result set. Previously, as you may know, we had to do selects with an inner select that did an order by, and the outer select did a limit on it by selecting X number of rows. Now you can do it all in line with the select statement. You can give it an offset, so you can tell it to skip so many rows. It defaults to 0, so if you don't specify this at all, it's just regular functionality. And then the other options are fetch first, fetch next, and you actually specify either a row count or %. So you could say fetch first 10 rows. And then your second option or third option here is only or with ties. So if you execute a query and you say I want the top 10, fetch the first 10, and you say only, you will only get 10 rows back. If you fetch first 10 with ties, you're going to get the 10 rows you would have gotten, and that 10th value, whatever that is, if the next value is the same, it's going to include all of those rows as well. So you could actually, if you specify with ties and you're expecting 10 rows back, you may actually get 11, 12, 15, or 20, depending on what the last value in that sort criteria is. So whatever column you sorted on, if that sort value is the same as the next record after 10, it will get included as well. All of this the default rows returned on this is 1 if you don't specify anything, so you just get a single row back. So if you say fetch first rows, you would actually get just 1. You can't use it with a sequence column, so you can't fetch it based on the next val or current val. And it can't be used for incremental refreshes of materialized views. So you can't go and get a subset of the rows and try to use that to refresh a materialized view. If you do specify for offset, again, it defaults to 0, but if you specify a 0 or negative or a null or a number larger than the result set that would have actually been returned, you will it'll automatically default to that 0. So you can't actually put a bad value in there other than the true offset. And here's an example of that where I'm just selecting from DBA segments. I'm getting the top 6 segments based off of their bytes, the size. So I order it by descending. And now, again, I don't have to do all the inner selects and the outer select filtering. I just say fetch first 6 rows only, and I only get back 6 rows. Likewise, if I run that same exact query and I say fetch first 6 rows with ties, notice I get additional columns or additional rows that are returned because their values match the same value as the 6th row that was originally returned. So if you're planning for this to do pagination, or you're using this to only populate something on the client side and you only want a certain number of rows, then you do not want to use the with ties. The with ties might be more applicable in a case where you're doing some sort of analytics and you need to pick up those values as well. Concurrent stats gathering. We've all had to analyze tables in a schema or an entire schema, and it could have anywhere, hundreds of tables, and that used to run serially unless you did something on your own to programmatically gather that concurrently. You now have support for gathering it concurrently without doing all that. It actually uses the Oracle Job Scheduler and some advanced queuing, and it'll actually queue those tables up, and it automatically determines this, by the way, based on the available resources. So you don't specify, I want 5 jobs or 10 jobs. It does it automatically. You must have a resource manager plan activated for this to work. If you try to do it without that, it'll actually give you an error telling you there's no resource manager plan activated. So you will have to implement resource management if you don't already have that. I did it with a test and actually used Oracle's default maintenance plan. So you could get by with that if you didn't want to go through the hassle of creating the resource manager directives. You do need to set a global preference. Here I show it in DBMS stats, set global preference, concurrent, all. There's 2 or 3 different parameters to this, but this one I'm doing everything. And then I just execute a gather schema stats on this particular schema. And if I opened up another window and I looked at this DBA opstat operation task view, and while that stat was running on those few million row tables, I was actually able to see it populate this with the actual jobs that were running to gather stats on particular objects. And I basically took one of the tables and duplicated it like 5 times. And as I sat there querying it, I could see it finish one and start another. So in this case, it decided to do 2 at a time. This will be very helpful for those that have large number of tables that need to be analyzed, and you have the processor core count that it can actually take advantage of that to do it all concurrently without impacting. Also, if the table is partitioned, it will gather the stats on the individual partitions concurrently. You had that option before in 11G, but you had to call a special package to schedule and do it. Now you can just do it with the gather schema stats. You don't have to go through the mess of actually defining calling the procedure that did that before in 11G. Online stats for bulk loads. I really like this one. If you do any kind of data warehousing, data mart, staging type table loads, you know that when you do these loads, if they were frequently truncated and loaded and truncated and loaded, you had to build in the actual stats gathering as part of that process. You do not have to do that anymore if that's the kind of scenario you have. the statistics are automatically added as part of bulk load operations. And the key word here is bulk load operations. So if you do a create table as select, that's going to automatically put stats on the table that's being created. And also if you do an insert into select. Now, unexpected feature here, the documentation does say that if you do an insert into select, just that alone would be enough to gather stats. But I have found that that's not the case. The insert into select could be loaded conventionally. So if you look at the explain plan for that and it says load conventional, it's not going to put any stats on the table. You can force it to do that all the time by putting the append in. Another note of this, though, in using this feature, is that if you don't truncate and reload, and you load and subsequently load again, this only works for the first load. Why, I don't know, but it apparently does not do it after the first load. So you can do an insert into append 10 times, and whatever the first insert did, that's the stats you're going to have. So I call that the unexpected feature of this. It does not gather stats on indexes, so it basically targets just the table load. It does not create any histograms, so if you go and look at the stats on the columns that are created, they'll have stats, but they won't have any histograms. It'll all be none. If you use you can actually specify one of the options, gather auto, and that will gather stats without regathering column stats. So if you do a bulk load, and then now you want to come along and actually add some more stats to it, you can actually say gather auto, and it won't recalculate all the column stats that it previously did. And you will see this in your explain plan as a optimizer statistics gathering. So if you run an operation and you don't see that in your explain plan, you're not going to get the stats on that table. And again, this shows up when you actually do the insert into versus the insert append. You can see the differences there. It actually puts in the notes. There's a column in the user tab column statistics called notes. Inside that notes column, it'll actually say stats on load. So you can actually see that it did that as part of that bulk load. Also, I didn't mention it here, but it does also work with global temporary tables. So the same operations, if you do it in a global temporary table, it'll add them in at a session level, which is kind of cool in the sense that if you have 5 people using the same global temp table, previously you had stats for the global temp table. Well, now you get stats on a per session basis. So if I load 1,000,000 rows into that table, I will get stats that say 1,000,000. If someone else comes along and loads in 1,000, they will actually get stats for their session that shows 1,000. So that's all meant to help the optimizer figure out what's the best execution plan based on your session and the data you're looking at in your session. Here's an example of the online stats for the bulk load. So I do a create table, and I'm doing no logging, and I'm getting all the records from DBA objects. And then when I turn around and select the stats for that, I can see that it inserted 90,000 rows and 100% sample, just from doing the create table as. Then I came along and I said, okay, I'm going to do a create table as, but I'm going to create the definition only, and then I'm going to select to see what the stats show. Everything is 0, which you would expect. Then I insert into, and this is the case where I'm proving that without the append, it doesn't actually do what it's supposed to do. So I select from it after inserting those records. The stats are all still 0. Truncate the table. I insert append, and as part of having the append on there, I get all the rows that I did when I did the create table as. So I don't know if that was intended or not by Oracle, but that's the feature. Again, I talked about session stats for global temporary tables. Again, before pre-12c, you had one set of stats for the temp table that's used by all sessions. That would not necessarily lend itself to the best execution plan for your session if you were dealing with a small set of rows compared to someone else's large set of rows. Now those will be session private, and you can see that when you look at the stats. You will not see the stats from someone else. You'll only see the stats for your session. If you do not have set stats in as part of your session, then it will actually use shared statistics. So again, this kind of reverting back to the old way. If there's stats there and you don't have stats at your session level, it'll automatically use the shared statistics. And you'll see that when you actually query it, it'll have multiple rows for stats. And here's an example of how I proved this with the session stats for the global temp table. I created on commit preserved rows, selecting from the same DBA objects, creates a table. I look at that and it shows 90,774. Open up another session and do an insert append into that same temp table. And this time I'm only getting 3 objects. And when I look at the stats now, it only shows me 3. So it is truly session-based for the statistics. Flashback data archive. This is available to you in 11G. It has been enhanced, although in previous versions, I believe you had to actually have a license for this. They actually removed that restriction in 12C. Every licensed edition now is able to make use of Flashback Data Archive. I think this is one of the great things they've added. You can't do compression unless you have Enterprise Edition and you get the actual advanced compression option pack. It replaces the entire trigger approach that we used to use to populate history tables, so no longer trying to maintain a trigger on a table that populates another table that we've created for history, and then worry about the nightmare of any kind of table definition changes that could break the trigger, break the app. That's all gone. This would eliminate that totally. You designate a table space to hold your history data, and you also get to specify a retention period for it. So you can create table spaces that are based on regulatory compliance with maintaining data for X number of years or days, months, whatever it is, and not have to worry about the purging of that. It'll automatically purge the records from there based on that retention period that you've specified. When you create the table, or if you wanted to come back and add this later with the alter table, you just need to have the specified flashback archive. It's a great feature if you need to look at historical data at a point in time, or if you need to correct data that's committed to the base table. So if you have a table and you're maintaining the history with Flashback Archive, someone goes into the base table and updates those records or deletes the records incorrectly, you can always go back and get the flashback data. And it is now supported with most of the common DDL commands against the source table. So adding a column, modifying a column, dropping a column, all of that is being maintained. The archive is being maintained as well, even though you've done those DDL commands against your source tables. This should eliminate a lot of headache for some DBAs where they're having to implement regulatory compliance. In-database archiving, another great feature. So it's an enhancement piece to the Flashback Data Archive. Again, you have this with any edition of Oracle, licensed edition of Oracle that you have. It will actually mark the table rows as invisible, so now you can get away with logical deletes without physically deleting them. Again, the row is still in the table, it's just logically deleted, or marked invisible, I should say. And all you have to do to implement this is just alter the table and say row archival. When you do that, it's going to add a hidden column to the table, and the Aura archive state is that hidden column. It doesn't show up when you do selects and describes, but it's there. And it carries 2 values. Either 0, it's active, meaning this is the default. You insert a row into the table, it becomes active. If you want to archive it, you can actually update that using DBMS ILM, which is the Information Lifecycle Management Package, and set the archive state name to either 0 or 1. Or you can actually call that Aura archive state in your update statement and set it. So either way, whichever one you feel more comfortable with. To me, it just kind of makes more sense to use the Aura archive state. Again, it doesn't show up when you do a describe, so nobody ever sees it. It can actually be changed at the session level to view the rows. So by default, if you update a row and you set that to archived and you select, you don't see it. If you do want to see those rows, you can actually alter your session and set the visibility to active, and you will be, or all, and you will be able to see those. So it's either all or only active records. It is ignored if you do a create table as from a table with invisible rows. So if we've marked a table with the row archival, and then we turn around and do a create table as on that table to a new table, we will not, it will not carry over the actual archive state column. So you would have to re-implement that on your copy. A very interesting, unexpected feature again on this is export data pump. And also I actually verified this with SQL Developer. If you go and generate the DDL from SQL Developer, or if you export the table and then do an import to a SQL file and look at the DDL that it actually generated as part of that, it adds on to the create table statement the phrase ILM enable lifecycle management, which does not work. So if you copy that from the SQL file, or you copy it from SQL Developer, and then you turn around and paste it to try to run it, you'll actually get this Aura 933, SQL command not properly ended. And it's because nowhere in the documentation does it say lifecycle management is a valid option to ILM enable. So there's actually a different value that you would put there if you wanted to be able to take that code and then rerun it. The Aura archive state, again, it's only 0 or 1. It's numeric there in my slide. You can pass it a numeric value, or you can pass it as a character value. It's a varchar1 data type. And again, if you try to cut and paste this, you could actually get, in addition to the SQL command not properly ended, you can actually get an error message saying the feature is not enabled. Do not attempt to use this feature, even though this is a feature that's available to you regardless of your version. I found that to be very interesting, that it actually says do not attempt to use this feature. And again, if you have Enterprise Edition and you have the advanced compression option, these rows that are marked for archival will actually get compressed. So there's an advantage in the size of the table when you have those two licensed products. If you don't have that and you have standard edition, then the rows stay in the table is still the same size, it's just logically deleted and users don't see it. Here's an example of the in-database archiving. So I alter this table I created previously called objects, and I just say row archival. I describe it. Nothing's changed about the table. I don't see any additional columns. I can specifically select the column though. So if I select the columns of the table and I specify the Aura archive state, I can see that it put a 0 in that value. I can turn around and do an update. And again, this is a method of updating it using the ILM package. I could have easily said Aura archive state equals 1. Updates a row, and then I turn around and say select that, and I get no rows, because now it's no longer visible. I didn't change anything in my session to say show me invisible records, so I get no rows back. Again, this is a great logical delete if you have that requirement. If you do, I mentioned this before, if you do a create table as, in this case I did with the table that has the Aura archive state on it, and it copied it, I no longer get that column. So you have to be aware that if you're replicating these tables, it's not going to replicate for you. Another great feature, temporal validity. So this is another enhancement to the existing flashback data archive. You now can flash back or flash forward, depending on how you've defined this and how you've selected data from the table. It basically creates a time dimension to your data. So all the people out there that have data marts have dimensions, and in these dimensions you're maintaining this begin date and end date to mark when a record might have been good at a given period of time. So we were, this would be the slowly changing dimension type 2s. You were maintaining that yourself with ETL logic. You now can do alter table, add period for, give it a name, and what it does is it puts 3 columns, and they're hidden, puts those 3 columns in the table, and they're automatically named based on the name that you gave it for a time name. So in this case, if I said alter table, add period for valid, I would get 3 columns that would be, one would be valid, it would be defined as a number, and what goes in that number, it appears to be like a SEN number, so that's how it's tracking some of that. And then the next column would be valid underscore start, and then valid underscore end, and those would have timestamps associated with them. When I am ready to use that particular dimension, let's say, and join it with a fact table, I could actually select the records and say as of period and give it the name that I used, which valid in my example I'm describing, and then give it a date time. And for that, it will automatically select only the records that were effective, basically effective, business effective, not transactional effective, for that time period. You can call the DBMS flashback archive package and set enable at valid time and set it to one of these, meaning all records. I only want the most current record, or I want the current as of a certain date time. If you call that package in advance to your queries, then you would automatically, apply that criteria to, or filter, I should say, to your query. And it actually does just that. It actually applies a filter to your data. You'll see that in Explain Plan where it's doing greater than or less than filters. For data pump, we've all had to do large data pump exports, and in that, you basically knew it started at a time, and hopefully you formatted the time correctly so that when it ends, you can see that particular piece, but you didn't know what actually took the longest in there. In 11G, you did have the ability to say metrics equals yes, and so you could get a message that for each class of objects that it was exporting, you would get it took X number of seconds. But if you had 500 tables, you would get one time for all 500 tables with metrics equals yes in 11G. In 12G, you can add a log time, and this will actually stamp the log file for every single step in the entire export. Lets you see exactly how long each process takes, table by table, class by class of objects. You can specify these following different values: none, which is the default, and that's kind of giving you the backwards compatibility. Your log file will look just like it does today in 11G. You can say status to get status messages only. You can say log file to get log file messages only, or you can say all to get both. Interestingly, the feature is there, but if you did a export DP help equals Y or import DP help equals Y, you won't see it. It doesn't show up in the help. So they haven't updated that. And it is a lot more readable than using the metrics equals yes. Again, it didn't summarize on a per object basis. Now, if somebody asks you how long did it take for an export to run, or how long did it take this particular table in your export to run, you would actually be able to provide them with that information. So here's an example of what a log time for data pump would look like. Here you can see that it's actually putting in every single step is a full date time with some fractional second part of it for every single object in here. And at the very end, it adds the actual total elapsed time. So this is pretty cool for people that did need to be able to report this back out. You can also, in Data Pump, export views now, and you can export them as a table. There's a new keyword added, views as tables. This will actually export the view as a table definition and export the data from the view and be able to use that data to create, and that table definition to be able to create it on the import side as a physical table with rows in the table. So import will create the table and import the data into that table that you define. It also allows you to create a subset of data without having to use the query option. So if you had a complex type query option and your query option changed across multiple objects, you could theoretically put a view on those and export those views and get exactly the rows you want with whatever complex query filter you wanted to apply on a table by table basis if you wanted. Or even in joins, if you were taking, let's say an example might be you were taking a relational database set of tables, and now you wanted to more denormalize that and use that as a load into a staging table for a data mart, you would be able to extract that if you were using Data Pump. You'd be able to extract that as a flat file structure, basically, denormalized using the views on your source system. It is much faster than importing when you're using network mode. We all know if you're going to use a database link and extract data, and you have a billion row table in your source, and you need to apply a filter clause to that, depending on what that filter clause was, you could actually get all the billion rows coming across the link, and then you would filter it on the target. That is much slower than being able to put a view on the source, extract it as data coming through the network through that view definition. The query will be applied over on, obviously because of the view, it'll be applied over on the source system. The syntax for that view as tables is you specify the schema name, the view name, and then a table name. And here the table name is not the table you want created on the import. This is the table that Oracle will create internally on the database while it's processing all these records, or to get the metadata basically. So it's basically a template used for the export to get the metadata. The default name, if you don't specify that at all, it'll default to this KU $view as table _ process ID table. And then that table will automatically go away when it's done. No logging for import. So now you actually can specify with a transform parameter, in addition to all the other transform parameters that are already there in 11G, you can actually say disable archive logging. So now you can actually do an import of a large table, especially if it's going into a warehouse on a staging table. Maybe you want to be able to do that. No logging, you would be able to do that now. Previously, you wasn't able to do that. It does disable the redo logging for only the table and indexes. If you do have force logging turned on, obviously it's going to disregard no logging, and you're going to get force logging anyway. So it won't violate the force logging setting. And it still generates some of the redo related to the operations that it has to do, the import has to do based on the master table and some of the create and alter statements. So you'll get minimal logging nevertheless, but for the big import, you could specify no logging. Here's another great feature for those that have to load databases based on CSV files, flat files, that kind of thing. And if you've ever dealt with those, SQL Loader, creating the controls files for those can be time-consuming or be a pain sometimes. You now do not have to waste time with creating that control file. There's an express mode to SQL Loader. You just basically give it the table that you want to SQL load, and Oracle is going to automatically create the actual control file for you. If you look at the actual log file when this runs, and here you can see it shows up as express mode load. In that log file, you'll see where it does the create control file. It uses that control file to do the load. It creates a directory object based on whatever directory you're currently in. So if you're in the directory where the flat file is and you say SQL load, here's the table, it'll automatically create a directory object for that directory you're sitting in, and then turn around and create that external table, do the insert of the data, and then it drops the directory object afterwards. All that is in the log file for you to see. Obviously, you could have did all that manually, but this literally just takes a few seconds to do. The only stipulation is the table must exist on the database already. So if I'm going to import census data, I need and I specify census data here, it defaults to looking for the table name that you're specified with the DAT extension. You can override that, but if you wanted to get purely simple with it, that's all you really need to do. You can do things like change the order of the column, so you could have the column definition be a little bit different than the source file, and if you know that in advance, you can actually specify the field order so that it correctly gets the data in the right columns. But literally, you can do this in seconds, as opposed to spending many minutes defining the control file and getting that right. And if you do a list of all the SQL loader commands that are in 12C now, you'll see a handful of them that are all specific to express mode. You can't use them unless you're using the express mode. Online DDL operations. So previously in 11G, if you tried to do drop index online, you would get an error, resources busy, no wait. That still exists, by the way, as I list that as an unexpected feature. That exists if you're doing a bulk operation. So if I'm in one session doing an insert append and I do a drop index online in another session, I'll get that resource busy error. If I'm not doing a bulk operation though, and I'm doing a load conventional, I can the drop index online will actually sit there and wait for that session to finish, and as soon as it finishes, the index is gone. So it behaves like it's supposed to as long as it's not a bulk load. So this right here should help minimize some application outages as you do schema maintenance as part of application deployments and such. It does not require, again, it does not require the blocking locks anymore. Invisible columns. You can add a column and control whether it's visible or not from a selector describe. This is pretty neat because this allows you to do code deployments where you may be adding a column and you haven't released a new version of the app to take care of that column yet or to utilize that column. And your old code is doing a select star. So if we were to do that today in 11G, immediately after executing that add column, and the code does a select star, but it doesn't know what to do with that column, that breaks. The code would break. Now you can actually add it and say it's invisible. And when you do that, you can actually, and in this example, I show that where I create a table, I give it first name, last name, and title. And I insert some data in there, and I select from it so you can see the three values. I turn around and do an alter table, and I add another column, and I mark it as invisible. The same code session from previously does the select star from the table. It doesn't see the new column that was added because it's marked invisible. However, if you had another set of code that you were now rolling in to take advantage of the column, as long as you specifically specify it in your select, you will actually see it. So in this case, I'm saying give me the middle initial, and now it shows up as the output. This is great for code deployments where the app and the database deployments might not be in sync at the exact same time, which sometimes is not the case unless you take an outage. So this would help alleviate those issues. RMAN, so some of the command line enhancements to RMAN now is you can actually run SQL right from the command line. So in this case, you can see I run a select statement from a table right from within RMAN. You couldn't do this before. You could do some SQL statements, obviously, but they had to be prefixed with SQL. You don't need to prefix anything with SQL anymore. It just understands the SQL. You can actually do within RMAN, I do a describe on a table, and you can actually get the table definition. So SQL commands enhancement inside of RMAN. Another one is Resource Manager Runaway SQL Management. So you could always have Resource Manager directives, previous Oracle versions. In this version, though, you can actually take actions based on what the session's doing. So if you have a session that you see is an ad hoc query or something, and it starts to consume more than the amount of CPU or physical or logical I/O, you can take an action based on that automatically as part of the resource manager. And those actions here are, you have a few options. You can automatically switch the session to a different consumer group. So if they were in a high priority group and now they're ad hoc runaway, you can have it automatically switch them to a lower priority group to throttle back their resource usage and not affect, maybe your more sensitive OLTP application or whatever. You can actually tell it to cancel the SQL, terminate the session. So that's, really chop it off. And you can also do execution time limits. So you can say, this is supposed to run in an hour. It's been 4 hours. I don't want to get woken up in the middle of the night because I have a process that needs to be killed 8 hours later. You can actually set a time limit on it. It'll automatically see that it's exceeded that, or that it's going to exceed that execution time limit, trap the error, and automatically reschedule that for a later time. So some actionable items that you can take based on SQL, I/O or resource type consumption. Enterprise Manager Express. So I kind of show you what the screens look like here. If any of you have dealt with the Oracle Enterprise Manager 12c, this looks familiar to you. The days of Enterprise, the actual database DB console is gone. There is no more DB console in 12c. This is what you're left with instead. Enterprise Manager Express has the very same look and feel as grid control. So I really don't want to go into any details of that other than expect the whole look and feel to change. If you're not used to grid control, you might like it. I mean, some people like it, some people don't, but it has a pretty neat interface for some of the things that are grouped together. Queryable patch inventory. So now, instead of going out and doing an OPatch LS inventory on your system, or in the case of rack, going to every rack node and doing a query to look at the inventory at the command line, you now can actually make a package call, dbms q OPatch. You can run that from SQL Plus. That'll automatically get the OPatch inventory and be able to bring it back to the screen for you, just like a SQL Plus session. There's a half a dozen or more procedures to this Q OPatch. Some really cool ones to actually look at individual bugs, show me the bug one-off patches. So just about a lot of the individual features you could do with the OPatch, you can now do with this package as well. This now allows you to kind of write your own reports, or especially if you want to do comparison between environments, all from SQL Plus or from a tool that you're used to using SQL against, you can do comparisons. I think that's pretty cool. Another one I thought was pretty neat is Clusterware What If command evaluation. So there's times where you might need to make a change to a resource. You might need to make a change as far as start and stop or deleting things. Now you can actually run a what if, or in this, the command here is eval. You can run an eval on it and it'll actually simulate doing it without ever actually physically doing it. So you can see the impact if I were to do a CRS-ETL eval stop resource. What would be the impact if I stop that resource? Now you'll get all those dependencies that'll tell you, you can't stop it because there might be a dependency on ASM or whatever other dependencies you might have actually set. Listener, all those things now will actually give you some insight into the impact of making that change before you make it. I think that's pretty neat. OCR Backup, so if you're using rack or you're using ASM, even in single instance, you know that the OCR backups are automatically stored in whatever node is the master node. that's automatically taken every 4 hours, one every day, one every week, and then Oracle automatically manages the retention on those. Now you can actually put this file in ASM. Now all the nodes can see these OCR backups. If you have a 6-node rack, and I've messed with 6-node racks before to where the backups one day could be on one node, and next week, as a result of maybe doing roll-in patches, that backup is now changed to another node. There's no automated way of saying this is my backup, other than show. You can do the OCR show backup, but you went looking for that file or had to go to a node for that file. Now it's available from every single node. It does require, if you want to implement this, it does require that the OCR be located on an ASM and in a separate disk group. So if your OCR is already in ASM, some people on 11GR2 put OCR information, the actual registry in ASM as opposed to a clustered file system. You will need to have the OCR in ASM, and then you will need to have a separate disk group that'll be used for the OCR backups. So that's the only stipulation or requirement in this case. You also have some additional I/O outlier views. This will actually track the I/O latency. If it exceeds 500 milliseconds, you'll get entries into these views that tells you what operations were either occurred or are occurring that had a high I/O time. So you might see things in I/O outlier if you start seeing parallel control file writes taking a long time, the log writer taking a long time. They'll actually show up into these views, and it actually shows you the latency in the view and shows you what kind of pack or block size it was trying to use and how much latency it was doing at the time. You also have one for log, specifically for log writer. So log writer operations will be in that one only. If you're using Solaris as your operating system for your database, you can actually use kernel outlier. It's only available for Solaris, not on Linux yet. This will actually break down the Solaris kernel components and show you where the latency is in that. So that one, if you're on Solaris, I see that as being a huge benefit for performance tuning or latency. When somebody's complaining about something slow, you can go to these and see if this is what's occurring. Another interesting one is the multi-process, multi-threaded. So if you go out and do a PS-EF today, and you grep for aura underscore whatever, you'll get 40, 50, however many databases, you'll get dozens and dozens and dozens of those processes show up in that. Now if you implement multi-process, multi-threaded, you'll actually get sharing of those processes on that database. And here you see where I had 40 before I implemented this, or well over 40. And then I did an alter system, set threaded execution equal true, scope, bounced it. Now when I do a PS-EF and I grep for the processes, this is all I see, 6 processes, and that's it. So this might be really good on dev and test environment. It might be good on production, but on dev and test where maybe your number of processes or process limit may be more constrained than production, you can actually implement this threaded execution and allow that to be a lot less processes that will be shared amongst the processes inside of Oracle. So they'll actually make use of these processes. They will spawn up other ones if it's needed, and then those would be multi-threaded as well. So this is not like a definitive list. It's based on whatever processes you have running or you may execute. But it's still a vast number smaller than what you would have had without multi-threaded. Code-based security, I think this one's a cool one if you deal with any kind of regulatory compliance where security, you have to be able to do a least set of privileges approach to granting permissions. You now can do grant roles to procedures, packages, and functions. That role then eliminates the need to grant those roles to the users, but typically you grant them to the user to execute a procedure or to execute or select something inside that procedure if you were doing with the current auth user or definers versus invoker rights, depending on how you define that. you might have to actually over-grant permissions to do something that a procedure needed to do. This kind of eliminates that. So now the users are not granted access to an entire object, but just a subset of the data in that procedure. And in this example, I kind of walk through the steps that you kind of take to do that. So you create a procedure, you put the auth ID as the current user. In this case, I'm creating a procedure to show employee records or all employees in a department, depending on what your role is. Then I grant execute on a procedure to a particular employee. I create a role that has a select privilege on that table. So I'm not granting the select to the user, I'm granting it to the role. I turn around and grant that role to the procedure. And now when the user calls the procedure, they will only get the procedure is filtering out based on your role. They would only be able to see those records. They can't use the select table privilege to go look at all the rows or look at the entire table anymore. So now you kind of can get some of that application security model pushed into the database and let the database enforce that. This one requires some rework to application, but I think it's worth it if you have to implement that type of security and be able to account for least set of privileges approach. There's also a new unified auditing. So traditionally we had audit, so we had the audit sysaud $, the FGA one, and if you're using Data Vault, you would have had a DB sys audit trail. All three of those, three separate tables handling different types of auditing data. Now you have unified auditing, which brings all those three tables into one single view. That's called Unified Audit Trail. You can see all the records from one spot. It does write to, I mentioned that it's always enabled, so there are a set of auditing commands that you can never disable, and you can never turn off, and you can never change them. And these are operations by, you see the users I listed here, sys, sysdba, sysop, those. When those occur, if you log in as sysdba, that's going to be audited. You cannot not audit sysdba in this case. It writes to the audit trail in one of two methods, and you control this. You can either have it queue up to the SGA and then write to the default, or write to the disk, which is the default, or you can have it immediate write mode. If you're going to have it queue up and then write to the disk, the default is 1 meg, and you have to, for this parameter, this SGA queue size, it's 1 meg. You're allowed to go up to 30 meg on that. Again, it's a single view for all your audit records. It's created stored in tables, created in a new schema that's added to the database. It's ODSys. And it puts in that ODSys table, it puts those records in read-only. So now you can't go and delete from it like you literally could do with $. You could go and delete records from there, truncate it, or whatever. Now they go into read-only tables, into a read-only table space that supports that view, and you can't really circumvent being able to say I didn't or didn't do something because it got logged into an audit trail. Again, the security model in this becomes much more tighter for regulatory compliance. I didn't mention here, but I wanted to mention that when you are writing to the queue to the SGA, that defaults to every 3 seconds. So if you do every 3 seconds, it's going to flush that to disk instead of the immediate write mode, which would be immediate. It could take a little longer than 3 seconds, so it tries to do it every 3 seconds, but if the database is under a heavy load, it might be 4 or 5 seconds. So just know it's not a definitive 3 seconds. And you can force it to flush immediately if you want. There's a new package or a new procedure in the DBMS audit management package, and you can say flush the audit trail, flush the unified audit trail, and that will get the records out immediately. So you have some control over that even if you're queuing. Last login, this is more of a tidbit. I don't know that it really helps anybody other than being able to just see it where you couldn't see it before. As far as the banner, I do think it's nice that they added that into the actual user table. So the DBAs can actually query the user $ table and see exactly when a user last logged in. That'll be stamped in there using a timestamp. You can see that in DBA users. Column name is last login. Also shows up in the SQL Plus banner. So it shows last successful login time. So very similar to what you might see if you logged into a Unix server or something. Role defaults. If you're going to 12C, you haven't gone to 12C and you're going to 12C, you need to know about some things that have changed. One of them is the role defaults. The resource role no longer contains unlimited table space. You have to explicitly grant that now. The select any dictionary removed access to some of the $$ and like the link $, which had previously would contain or could contain passwords for database links, default passwords, user encrypted passwords. Now those, if you grant select any dictionary, you would not be able to see those. Those have been removed. Like following on the separation of duties, again, auditing, you can actually selectively assign users admin or view-only privileges for auditing information. So if you have a case where you have somebody who maintains audit data, but then you need to give view-only access to audit data to somebody who's doing an inspection or security audit or auditors, you can actually create a separation of duties using the roles assigned to them to be able to view it versus modify and delete it. So a little enhancement on the separation there. On the RMAN side, you get a sys backup now. Now that particular sys backup privilege allows you to do the backup and recovery, and it eliminates the need for you to do sysdba privileges. So if you do have staff that does specifically responsible for backup and recovery, they don't need the sysdba privilege to go in and do some of the backup RMAN operations that they had to before. Multi-tenant architecture. This could be a whole hour-day presentation all of itself, but what I want to do is just kind of broadly cover some of it, maybe kind of introduce you to it in the layman's terms, and then we'll talk about what you can't do depending on your version. So overview in simple terms, introduces new concepts. One is called a container database, and all the other databases are called pluggable databases. A container database is nothing more than a root. There's only one of them, one to many between container and pluggable, that is. The container database is going to contain all the objects that are common across all pluggable databases. So a lot of the data dictionary stuff for the users and table spaces and things like that are all going to be common, and that's in the container database. There's exceptions about having additional, and you will have additional of those in a pluggable, but this is the core part of the database. When you create a blank database, those objects that are in there, most of them will all be in the container database. It also includes, as default, a seed database. And that seed database contains all those shared database objects that would be needed in the event you create a pluggable database. So it's kind of like the seed data for that, the data dictionary view stuff. You can have up to 252 pluggable databases in one container. You can only do that in Enterprise Edition. Unfortunately, in Standard Edition, you can only have one pluggable database in a container. We'll talk about why you might still be able to use that, but for the most part, the Enterprise Edition folks are the ones that can make use of this immediately and probably have a good impact on resource utilization on servers. So instead of having 100 databases self-contained, you can have one container database and 100 pluggable databases in there. Each pluggable database is somewhat self-contained from a security model standpoint. Apps don't know anything different about. They can connect straight to a pluggable database. They don't know whether it's pluggable or not. When you do a patch or an upgrade, you only have to upgrade the container. All the pluggables inherit that. So from a maintenance standpoint, Enterprise Edition people, huge benefit. You patch the container, and all 100 of your pluggable databases do not need to be patched. They're part of that patch. You can create users in a container that then cascade down, so there's a little bit of a hierarchy here. You can create a container database user, and that user now has access to all pluggable databases, or you can create a user in a pluggable database, and he can't go back up into the container. He's isolated into that pluggable only. Pluggable database, so it's just a collection of schemas. Think of that as if you had a sales application and you had an HR application, you can have one core or one container database, and then you can have a sales pluggable and an HR pluggable. And each one of those are basically standalone. Apps would connect to them just like they would as standalone databases. The benefit is they're shared in a container. The benefit there is there's isolation and separation between the database so they can't cross over to each other, even though they're physically plugged into the same container. So this is kind of my little analogy for people that don't know anything about container databases and pluggable. What's a good analogy? This is for Enterprise Edition. Think of a container as this power strip. It has one source of electricity, has one on-off switch, it has some common set of attributes. Then we plug things into that container. And down here we have, example is like we have this object that has a print and scan. We have another object that has fax and scan. We have another object that has email. We plug them all into this one container. And now when we do things on the container patches, all of these would inherently get that benefit as well, the patching, without any downtime or any of that. Notice here in this picture that the first two objects, the printer and the fax machine, they both can scan. So you can actually have, in a pluggable database, a user in every single pluggable database, the same exact user, all in one container database. They're physically separated by that pluggable feature. So you could have an HR in one pluggable database and an HR in another pluggable database, all in the same container, all with different objects, all with different permissions. So this is kind of like the simple analogy. Unfortunately, if you're running Oracle Standard Edition, you just get one of those plugs. Not a whole lot of benefit for patching and things like that. However, you could actually use it to do some things that are beneficial in the sense of upgrades. So you could actually have a container database at one release, another container database at another release, and actually unplug it from one and plug it into another. That is very quick, it's fast. You would be able to move from one version of Oracle to the other just by unplugging and plugging in. Some of the features of this, I kind of mentioned there, but fast provisioning of new databases. You literally can create a new pluggable database in just a minute or so. You can actually make copies of an existing database, again, in a few minutes. So fast redeployment, simple commands to unplug it and plug it in. You can unplug from one, plug into another, take it to a whole new platform. You can quickly patch if you have you're just patching or upgrading the container. So done once, many databases benefit from it. Whether you have one pluggable database or many, the patch or the upgrade is kind of more so on the upgrade side than the patching, to be able to move the pluggables through different versions. A machine can run more database instances in the form of pluggables than it can in individual database. So if you have a server and you typically scale your servers, let's say horizontally, vertically, and you throw 100 databases on that, that is going to consume more resources than if you were to have 100 pluggable databases. One thing I didn't mention in this that's kind of key to why that statement is true is a container database is basically all your SGA components. Every pluggable database shares that one SGA. Each pluggable database doesn't have its own SGA. So now you can bring 100, if you're doing a more of a cloud on-demand type database architecture hosting environment, you could be hosting a database for every client. You could create and segregate those off, kind of like what Amazon does with whether you pick a small deployment or a medium deployment, sizing from a sizing perspective. You could get lumped with all the other smalls. That is much more better resource utilization than putting them all as individual databases. They all share a common memory structure. There's no loss of functionality or performance whether you have a single pluggable database or many. There's no loss of functionality or performance if it's pluggable versus just straight out standalone database. Here's an example of how I was able to move a database around. This literally took just a few minutes from start to stop. And granted, it was probably a little over 2 gig database, but I was able to unplug it. And here's an alter pluggable database. And I unplug it into an XML file. The XML file contains the location and the metadata for the database, so where all the data files are and things like that. Dropped the pluggable database from that database, and then I turned around and I said, let me put it back in the database, but I want it to be a different name now. So this is another benefit of how you might be able to use this, even if you have standard edition. So you can pull the databases out, rename it, and put it right back in. And in this case, I'm telling it, since it's the same pluggable database, I'm just literally changing the name. I want to reuse all my files, and that literally went from unplug to open in just a few minutes, if less, maybe 2 minutes. So there are some features, even if you're using standard edition. There are rumors that there's new data pump functionality, this new generation of data pump that's coming that will take more advantage of pluggable databases than it would if you did not have a pluggable database. So it's still encouraging, Oracle's still kind of encouraging you to do the pluggable database even if you only have one. So in conclusion, we talked about a lot of the new features of 12c. This is just a small fraction of, there's over 500 of them if you start counting all the functionality, if you had Enterprise Edition and some of the packs. There's literally over 500 of these new features. And we've only been able to touch on a few of them given the time, but the ones we did touch on, you would be able to use regardless of whatever database edition you have. What I recommend, most people don't jump on the bandwagon and be bleeding edge with the newest release, but now should be the time that you start planning your upgrade process for the next release. You should already start planning your environment and what it's going to take from either a deployment testing scenario to get ready for the next release. And again, NeoVera, we do assist with this. We do risk mitigation assessments for these so that we can look at your database and say, if you want to go from 11G to 12C, here's the things we'll look at to make sure that you're not using or try to use deprecated features, or if you're using features whereby they exist in 11 and they exist in 12, but the default behaviors changed, that's part of the risk mitigation. And then we either help you or we prepare an upgrade and implementation plan on that and do a post-upgrade review and then train staff on either what was done or the process or the functionality that they can take advantage of in the database. So at this time, I'll take some questions and answers if there are any.